Welcome to this preview of my course, Introduction to Semiconductor Devices, otherwise known as Electrical Engineering 4301, shown here, some of the specifics. My name is Robert Leibowitz. I'll be teaching the course, and my email addresses are below here. My Columbia email address, and I have an IBM email address also. I worked for many years at the IBM Research Center, and I still retain my address here, and I would prefer the Columbia address. I can also be contacted by phone and fax, and I have office hours, generally Tuesdays and Thursdays. The class is on Tuesdays and Thursdays, so the office hours are usually around it, but by appointment almost any time, and by email. Usually there's a teaching assistant in the class, and that hasn't been announced yet. Basically, it's a course where it goes into the fundamentals of how a device operates, and then the operation of the device, the fundamentals behind the operation, and then the operation of the device. And as such, I cover most of the prerequisites. So whatever it says in the bulletin, detailed prerequisites like advanced courses are not required. But, you know, your basic physics, chemistry, math courses are certainly good to have. There's a text in the book by Muller and Kamens. I was going to change text this year, but the new ones haven't come out yet. But this one's fairly up to date, and I update things as I go along. So you should be able to find this. The course is organized around, in the beginning, 8 homework sets, not too long, and due in class. CVN students send them in as CVN wants them to go in. The reason there's only 8 homework assignments in a 12, 13-week class is that the last few weeks are devoted to a mini project, and I underline and capitalize the word mini. It's a short presentation, usually the equivalent of 5 view graphs in length on some aspect of semiconductor devices, and that's due the last week. There's a variety of ways of presenting that, but there's also no homeworks due in that period. There's a midterm closed book, but I allow 1 page of formulas allowed on the book. This was on March 2009. Date to be announced. That's why I didn't put that in there yet. The middle of March typically is the midterm. 1 page of formulas is good. You don't have to worry. Not always interested in the derivation of the formula. It's just what does the formula mean and how do you apply it. The final is similar to the midterm, and the date is again to be announced. And I allow 2 pages of formulas there. Some people write really small, but it takes a long time to see really small writing, but that's up to you. The grading is roughly in this way. The homework, sometimes I have 20% for the homework, so that can vary. Straighten that out. That can vary. Project, midterm, and final. Okay, some more specifics for the class. There's a text. Oh, I'll just mention the text. I actually already mentioned this text. Text again, and I also give several references if people are interested in them. This book has a new edition coming, so I was almost going to use it, but it's still not here yet. And there's a book by Z here that's fairly recent. So, but these are handy, but not required. What's covered in the course? So here I have a syllabus. I have several syllabuses. Here's one. So in the first 3 to 4 weeks, this says the readings in the chapter 1, 1.5, chapters 1, 5.1, 5.22. And I don't cover the whole, there's not one whole chapter that's actually covered, so we do skip around a little bit. No, I make that clear. But in the first 3 weeks, we spent at least 2 weeks on introduction, semiconductor physics, and several more lectures here on basic semiconductor properties. Then we move on to PN junctions and a little sidebar on integrated circuit resistors. I like to emphasize that the devices always fit into circuits. So we'll have to go over that. Then we go the next 3 or 4 weeks, which also includes the midterm and spring break. Move on to bipolar transistors. And then we cover Schottky diodes, metal semiconductor devices, and I slip in a few ideas on tunnel junctions and a couple of miscellaneous devices at this time. Tunnel junctions are becoming more, tunneling properties are becoming more important for modern devices. It's good to know what's meant there. Then the end of the semester, we get into the MOSFETs, MOS capacitors, more integrated circuits. And in order to cover the field well, I generally have 2 outside speakers. One talks on heterostructures, and another one talks on advanced CMOS presentations. And as I say, in the final week, we usually have the mini project presentations, which is actually very interesting, a lot of fun. This is a wide variety of mini projects. And then, inevitably, there's a final. The course is also arranged in the following way. Let me see. Class notes. So before each class, hopefully I'm on time, but I've usually been, I give out a set of class notes. I'm tempted to put these on the web, but they are on the web for the CVN students. And they're usually half filled in, and I'll show what I mean there. And space is allotted for notes and comments that I go over in class or that the student may want to answer. It also provides a means of updating things. So as one quick example of my class notes, here's a lecture on drift velocity. Notice the large empty spaces allowed on the sheet. When I'm finished with this particular one, it should look something like this. And the question maybe on what limits the drift velocity, lattice scattering, phonons, and you go into low field and high field, and then define what the mean free path is. There's usually room for your own notes there also. And generally, if you miss a class, you can get a copy of my filled-in notes. Not that anybody will miss my class. The filled-in notes also allows for a little bit more complex diagrams, like this one here. I don't have to bother redrawing it. I can just show it. So that's the class notes aspect of the class. Oh, here I have one more syllabus to show here. This is a 1-page syllabus. Basically covers what we had before, but this should be on the home page also. Semiconductor physics, bipolar, PN junctions, bipolar transistor, Schottky diodes, metal semiconductor contacts, tunnel junctions, speaker. Tunneling effects come in first. Well, they come in several points. I shouldn't say that. MOSFETs, and then the mini projects. Just a final word about the mini projects. I give out a detailed set of examples and protocols here, but there's a very wide choice of mini projects. Some aspect of semiconductor devices is good, but I'll accept almost any device, actually. If you want to do a superconducting device, I probably will accept that. Yeah, having worked in superconductors myself. So a few examples of what students have chosen in the past. Semiconductor lasers, gate tunneling, silicon on insulators, CCDs, LEDs, lasers, a whole bunch of storage devices, diodes, decoupling capacitors, a very important thing, quantum weld structures. So people like to do, some of the people are more interested in fabrication techniques, so you can get into lithographic techniques and then some of the more modern nanostructures, molecular. And it's not necessarily, it's not called a mini research project, it's a mini project. You have to pick some aspect here and show that you understand it and show that you can explain it to the rest of the class. And that usually will ensure you have a very good grade on this part. So that's the course in summarized in a brief way. I'm available to, if you have any other questions before the class starts, you can email me, and if not, I'll be happy to see you all when the class starts.